we're really focusing in here is this is a little side jaunt, if you will, into psychometrics. So if we're talking about measuring individual differences, if we're talking about trying to identify how people differ in order to use those differences to make predictions about how well they'll perform, how well they'll fit, how well they'll be satisfied in a particular job or role, we have to at least be at some level aware of kind of the guidelines, the rules, and the science behind measuring individual differences. And a part of that, again, is to remember that we are basically talking about a house of cards. And what I mean by that is that the vast majority of things that we are interested in measuring, especially as predictors, are actually internal, unknowable, unmeasurable traits. Now, unknowable is a little bit of an exaggeration, but what we have to recognize is that if I'm measuring emotional intelligence, if I'm measuring openness to experience, if I'm measuring job satisfaction, if I'm measuring positive affect, all of these are not something that can be just technically and mechanically measured. We have to infer their existence, their distinctness, and their relationship to other variables that we're interested in. And a lot of times that measurement becomes kind of a complex process. Now, we have a tendency to focus on the end result. So probably all of you have a pretty good idea of how to measure various attitudes. If I asked you to create a scale, a measurement scale of people's attitude towards Dorito chips, you could probably come up with 4 or 5 questions on a various scale, figure out a way to make sure that they're asking various aspects of the enjoyment or lack of enjoyment of that particular snack food, and then you could probably figure out a way to test it. And again, one of the ways we could do that is simply to ask people, do you love Dorito chips or do you hate Dorito chips? Get 2 groups, the hate group and the love group, give them your scale, and if it turns out the love group scores very highly on your scale and the hate group scores very lowly, you've just done a little bitty miniature measurement study. You've created a scale and you've gone through the process of validating it against a known attribute, their own self-admitted level of likeness. But you also have created something that might give you a little bit more measurement ability in that if you just ask people, do you like them or not, that's a categorical variable. That's harder to use. We're lumping everyone into one of 2 categories. And those 2 categories may not be very good predictors of, for example, liking other snack foods. However, if we've now created a 5-item measured on a 1 to 5 scale on each of those items, Likert scale for instance, measure of liking Doritos, we now probably have a much more fine-tuned measure of liking of Dorito chips. And in that case, we can start making a little bit better prediction because we don't have a 50-50 split or whatever it turned out to be of the people that's yes or no. We now know that if people score very low on our scale, a 1 adjusted mean, we know that they really don't like Doritos. And if they score a 5 adjusted mean, that means they really, really like Doritos. But we also get 2s, 3s, and 4s. And probably most people, especially if our scale follows most psychological measurements, most people will fall more in the middle. I myself would probably rate myself as a 3 to 4 in my love of Dorito chips. They're not my favorite. They certainly wouldn't be a 5, but I eat them. I like them. So there we are. So I just want you to keep that in mind as we move forward, that the reason we're looking at this and talking about measurement is to make sure we have a good basis in the tools and methodologies we are going to use to try to infer innate individual differences that are often psychological, attitude-based, or personality-based that can't be directly measured. They have to be inferred. So to start with, just a quick review of the scales of measurement. So when we talk about measurement, the definition is the assignment of numbers according to a rule. So some attributes are easier to measure than others. Again, what we're trying to do is create a structured assignment system where we can actually basically using a set of rules, and the rules are often the actual items or questions that we're asking and how people respond to them and how we add up those items, how we actually create a final score. And this is also something that you really want to think about is what do you want that final score to look like? So I'm going to go back to my pretty bad example of our 5-item Dorito scale 5 Likert questions about whether or not you like Doritos and various aspects of Dorito snack chips. How we actually create the final measure is a rule, and it might be that we simply add up their 5 scores. In that case, if it's a 1 to 5 scale with 5 items, that means the scale would range between 5 and 25, with 5 being the very lowest and 25 being the very highest. We might decide, because it's already on a 1 to 5 scale, that we actually create the mean of those 5 items. And that means that we're probably going to get a number with decimal points, but it's going to again range between a maximum or minimum of 1 and a maximum of 5. So again, the rules are something that we're determining based on the scale and based how we want to use that measurement and how we want to think about it. And also recognize that it's easy to create rules for something that can be mechanically measured. For example, height, weight, diameter. Those are things that it's pretty easy to come up with. What are we using to measure it? What standard are we using? And how are we going to do it? The rules for determining how we're going to actually measure psychological constructs can be more difficult. Now, the first thing we want to think about is what type of scale of measurement can we get? And there's 4 levels, and we've discussed this in statistics classes, but I want to go over it again just again to remind you that the 4 levels are nominal, name only. So we are assigning numbers, but those numbers have no meaning other than to simply be another way to name an attribute. So for example, male and female, well, males are 1, females are 2. And the reason we would do a nominal measurement is for statistical purposes. We can't add male or female into an analysis, but we can compare group 1 versus group 2. Next is ordinal. The numbers now have at least order. So 1 is the smallest, 2 is the next biggest, 3 is bigger than 2, 4 is bigger than 3, etc. Or whatever the scale is. The scale has an order to it. So the numbers now matter. However, what it's missing is equal distance between those numbers. So just because someone's a 3 doesn't mean that they're twice as good as a 1.5. We don't know. All we know is that they are a 3 and that anyone below a 3 is lower than them on whatever we're measuring, and anyone above a 3 is higher, but we don't know how much higher. Interval is what we usually are wanting to shoot for. An interval scale means not only do the numbers have meaning, they represent something, nominal. They have order, so as they go up or down, those numbers matter. Finally, the distance between each number is roughly the same. And most of our attitude scales or Likert scales on a 1 to 5 or 1 to 7 are usually in this range. And finally, the final level, if we can get it, is the gold standard for measurement because we're starting to get to mechanical measurement again. A ratio scale has an absolute 0. 0 has meaning. Remember that an interval scale, an interval scale is still a nominal scale. The numbers are being assigned by a rule, not by any kind of logic or mathematics. So you might have a 1 to 5 scale, you might have a -2 to +2 scale, you might have a 100, 200, 300, 400, 500 scale. All of those are still 5-point scales. The numbers really aren't that important other than representing more or less of something. With a ratio scale, we now have 0, and 0 means none. Most psychological constructs are not going to be measured with a ratio scale because most psychological constructs exist theoretically to where there's not such a thing as not having any. You can't have 0 personality. You have some level of openness to experience. You have some level of emotional intelligence, even if it is very low. But if we can get to ratio, we want to get there because that means that we are going to have a lot easier time basically stating our rules for that measurement. A lot of times ratio data, especially in IO psychology, is behavioral data. How many times did the behavior happen? 0, it happened 0 times. 5, it happened 5 times. These 4 levels are hierarchically related, which means as we move up from nominal to ordinal to interval to ratio, they are getting more and more fine-tuned, more and more rigorous, and more useful, and we can do more statistics with them. They basically represent an increasing precision and a more powerful statistical analysis. For the most part, the vast majority of statistical techniques we use in industrial organizational psychology do require at least your outcome being interval or ratio. And a lot of times our prediction is going to be more believable, valid, and trustable if most of our variables are in the interval to ratio scales. So what's going to follow for the rest of this short lecture is basically item response theory, IRT, in an incredibly high overview. Item response theory is one of the key tools used in psychometrics. And psychometrics is the actual study of the process of measuring basically psychological or physical objects within psychology. So item response theory, honestly, is one of those things that if you were actually in a psychometrics program, you would probably have various classes on item response theory every semester of your graduate career. So I do want to impress upon you that the next 5 or 6 slides is an incredibly high-level overview, just hopefully enough information that if you're ever presented with IRT data, you have an idea of what you're looking at and you'll be able to ask some relevant questions. So item response theory is basically the traditional measurement is not objective. It depends on the test and the standardization sample. So what this basically means is that item response theory is not based on the mechanical measurement of mechanical observable events. It is a measurement theory for when we're measuring non-objective outcomes, psychological constructs. A personality test score would definitely be something that would fall under item response theory. It uses norms or standardized scores to interpret the test results. So it basically recognizes that every test is a product of the people taking it, and that it's a relative measurement of personality, that we do not have an absolute understanding of what personality is, what a 0 personality is, what a 10 personality is, but what we can do is say that this is this person's personality, and here's how it stands standardized as relative to other people that took the test. Are you in the top 10%? Are you in the bottom 20%? So in comparison to physical measurement, it doesn't matter what ruler or comparison group is used. In other words, if you're measuring someone's height and they're 6'2", it's irrelevant what other people's heights are. Their height is 6'2". If we're using item response theory, we are relatively connecting everyone's score to other people that have taken the score. So that's the first big idea of item response theory, is the recognition that the measurement of psychological constructs is dependent on the group of people that are taking it. So just knowing someone's score is rarely enough if it's a psychological measure. You need to know what their score is relative to other test takers or relative to a normed sample. And what a normed sample often will be, for example, is if you are actually creating a personality test that was going to be used to help you select top executives. The norm group might be an organization may go out and give this personality test to people that are currently in the role of CEOs of top 500 companies. They'll get a data set and they'll get a range of scores. What is the norm for this personality score in this extremely small group of people that are doing exceptional work? And that then becomes the bar that someone applying for one of these jobs needs to pass. And that might be a very high bar compared to what would be considered just a normal personality score or even a favorable personality score for an entry-level job. So another major part of item response theory is looking at each item as it relates to what it's measuring and the other items that are measuring the same construct. So an item characteristic curve is the probability of a correct response to an item as a function of the trait being measured. That's a pretty complex sentence, but what it basically means is that if we're wanting to look at a series of items that are meant to measure the same construct, we're going to compare each item to the person's overall performance on all the items. And what this allows us to do is to take a look at each item to ask how well is that item contributing or not contributing to the success of the measurement of that trait. And what we're usually estimating are parameters. The first one is A, discrimination, the extent to which an item distinguishes between high and low performers. We want items that have a fair amount of discrimination. In other words, if you score low on an item, and we truly believe that item is capturing the overall construct that all the items are measuring, then when you score low on that item, you should also score low on most other items. Likewise, if we think those items are all successfully measuring the same psychological construct and you score high on an item, we'd expect that you scored high on many of the other items as well. The next factor we want to look at is difficulty. So the ability level necessary to have a 50% chance of answering the item correctly. So again, we want to ask, not only does it discriminate, but is it an easy question? Is it a moderate question? Or is it a hard question? And we may actually change what kind of levels of difficulty we need depending on what we're actually wanting to measure. So again, if I'm making an entry level measurement of extroversion, I probably want mainly fairly easy questions. Probably about half of them I want them to be fairly easy. I will probably want about 25% difficult and only a few items that are truly, truly hard. I do want to discriminate, but I also am wanting a normed group that basically will tell me, is this person generally fitting the requirements that I'm looking for this particular role in the job? If I'm then using a very similar test, but this time I'm collecting again for a CEO position, I probably want a lot of difficult items. I want to make it to where, because if there was a bunch of easy items, there's a good chance that everyone would score well on the test. So the higher the level of skill or the more important that trait is to success in the job, that will vary how difficult we want the individual items to be. And finally, we do need to recognize the possibility of guessing. So the next thing we measure is C, how often, or the probability of getting a correct response with extremely low levels of ability. Now notice that item characteristic and item response theory and item characteristic curves are also kind of built around the idea of right or wrong questions. We still do use these techniques to evaluate psychological constructs, but they were designed in education. They were designed, honestly, for multiple choice tests. And if you actually worked, for example, for the GRE, you'd probably do a lot of item response theory, looking at their individual items, calculating the discrimination of each item, the difficulty of each item, and the chance of guessing for each item. So this is basically what we're generally looking for an item. So along the vertical axis, we have the probability of answering the item correctly compared to the overall ability we're measuring. And remember that most often what we're going to have on the horizontal axis, in this case verbal ability, is the overall performance on all of the items. So we're going to basically use the test on itself to measure individual items. And this would be something that we'd be pretty happy to see, because what this tells us that if you really aren't very good at the particular thing that's being measured, you're going to usually miss this item. And if you're about in the middle of the pack of people that are taking this test, you got about a 50-50 shot of getting this item right. So again, look at the middle of verbal ability, right between the low and high, and then track upwards to what's the chance of the person getting that item right. It's 50%. They're about 50-50 if you have average ability. And as your ability goes above average, your chances of getting the answer correct are much higher, up to the point where if you're at the top of the curve, almost everyone gets this item right. So again, think about this. This is showing us that the difficulty of the item also varies based on your actual ability. This would be a very good item that has a very good spread over the chance of you getting it right, and it's also fairly discriminating. You get this item wrong, there's a pretty good chance you're pretty low in the ability. Not a 100% chance, but it's pretty there. It's pretty solidly there. And if you get this item right, there's a pretty strong chance that you're actually fairly high in the construct that we're measuring. Now, if we actually got a response that looked more like this, and again, the probability of the correct response versus the total test score, this would be an example of an item that doesn't discriminate very well. So notice that if you were at the very low end of the total test score, you had about a 20% chance to get this item right. If you were at the very top of the test score, you only had a 40% chance of getting this item right. This is a difficult item that also doesn't discriminate very well. So it's hard for everyone, not many people get it right, and because not many people get it right, it also doesn't tell us much. So if I was just looking at this item and I knew your score on it, I probably wouldn't have a good guess of whether you are high or low in whatever I'm measuring. So this is usually something we're looking for as an item that may not be doing what we want it to do or may be too difficult. And again, item difficulty basically shows 3 items that vary in difficulty. So the higher the line is on the graph, the easier the item is. So A, for example, if you had the very lowest score possible in this test, you still had a 40% chance of getting that one right. And if you were at the top of the test, you had almost a 100% chance of getting it right. So that would be a discriminating but somewhat easy item. C by comparison, though, if you actually are at the bottom of the performance on the total of the items, you only have about a 10% chance of getting this one right. And even if you're at the top, you only have about a 70% chance. This would be a fairly difficult item that also still does discriminate. You are more likely to get it right the better you are. So IRT basically gives us person parameters, an estimate of the latent ability. So basically IRT is recognizing that we're measuring a psychological construct, whether it is knowledge through a multiple choice test or whether it's personality or some other variable. And estimating the latent curves is mathematically complex. So the process of actually conducting an IRT analysis on individual items, comparing them to other items, and creating those item graphs we were just looking at actually usually requires a very specialized program and a fair amount of math. Those tests, we also then create test characteristic curves showing us the relationship between the observed test score and the true ability measured by the test. In other words, we're going to get estimates of how often are people getting successful at it because of guessing. We're also going to get an idea of how much error there is in the test. So the use of IRT allows us to tailor the test, look at individual items, decide if we need to add or subtract them. It allows us to look at a bank of items, and if we want to make a difficult test, choose multiple items that are fairly difficult. If we want to make an easier test, we can choose items that are a little bit easier. We can also look for item bias with this technique. So this is what's often referred to as differential item function, DIF, and we would actually calculate a DIF factor if we were worried about item bias. In industrial organizational psychology, what we're usually going to be looking at for is the 4/5 rule. We're basically going to be looking for protected groups and to find out, does this item function differently for people that are legally protected? So an example of that would be that if we did a differential DIF score on males and females on one particular item and found that for females it was highly differentiating and most females got it right, but with males actually it was non-differentiating and much more difficult. This would be an item that would have bias. We have proof. What we're wanting is those two graphs to be very similar to each other. And we could also look for age, young versus old. We could look for various ethnicities and minorities, basically any protected group. We could do an item bias analysis to help us actually have a really good idea, how does this test work? And does this test work differently for protected groups?